Hello all, welcome back to Datacraft Institute. So today we will be learning module 5 which is related to subqueries and CTEs, and this module we will be covering in notebooks. So for those people who are not interested to learn notebooks, that is fine. The code remains the same. But if at all you want to be familiarized, you want to familiarize yourself with Snowflake notebooks, then this tutorial will serve dual purpose. It will show you how notebooks work, give you a familiarity with the notebooks, and it will also give you familiarity with the subquery and CTE syntaxes. So to start with, we will begin with what is a subquery, and then going forward we will see scalar subqueries and correlated subqueries and exists condition, how to use it, and then we will be learning about derived tables and then common table expressions, and then pipeline thinking with CTEs that would be helpful in your like DBT kind of scenarios going forward. And then we will be also looking into recursive CTEs, where we will be learning hierarchies, how they are built. Okay, and this is also very important. So yeah, so let's start. So if you are already familiar with notebook, well and good. If not, then you should understand, then let me tell you something, that you need to first connect your notebook. Okay, so you will just click here, it will be connected to a runtime, and it will take some time to connect, but since I had already connected a couple of times, so it took relatively less time. So this is the runtime that I am using. Okay, and this is basically the compute, the server that needs to run your Python and SQL, Python codes and everything. Okay, and if you have already familiarity with Snowflake, you would know that in, like for example, in SQL sheets you can give a context. Earlier it was workspaces or any SQL workspace. You can give a context like join master class or schema, the database and the schema. But in case of notebooks, you need to provide the context like this. We need to use that database and schema. Okay, so that's it. And to clear the result of a cell, you just click here and clear the clear cell results. As of now, that is enough for now. Later, as and when we will use it, you will understand. And this is a markdown cell. Okay, so every time you have a cell, you can create, for example, if you hover over here, you can create a markdown cell, SQL cell or Python cell, and you can execute that cell itself. Okay, and you can also use AI features over here. You can use Coco, and this will automatically help you to resolve your issues in your code. But yeah, moving forward, what is subquery? A subquery is a query inside a query. If you need the result of one query to help you answer another query. One more thing, in subquery we will traverse from inside out. For example, our requirement is to know the employees whose salary is greater than the average salary of all the employees. So first you will calculate the average salary. Okay, and then you write the query like select employee name salary from employees table, where salary of those employees is greater than average salary of the employees table. Yeah, one more thing before we proceed, let us familiarize ourselves with our data set. So first we will have the employees table. So this employees table will have employee ID, employee name, department, salary. Then we will have the department table, which have a department ID. Employee and department are joined using the department ID. Okay, and then department name, each department has a budget and each employee has a salary also. And then there is org chart, employee and manager relationship. So CEO has employee ID 100, and then VP of engineering, you see manager ID is 100, means they report to the CEO. Similarly, engineering leads, who has a manager ID of 200, which is VP of engineering. So leads report to VP, senior software engineer report to leads. They have a manager ID of 300, which is a lead ID. Similarly, this will be helpful to understand this organizational hierarchies in CTs. Okay, so moving forward to execute it, let's just execute this cell and let's see the result. Okay, so if you see Alice, Bob and Charlie has an average salary greater than the average salary. To see what is the average salary, let us just take this query and move it into a workspace. Okay, so in notebook, it will execute the entire cell, but to execute individual queries we will have to copy to the workspace. So the average salary is 90,833. If you see, these salaries are greater than that. Okay, now the inner query answers what is the average salary, and the outer query answer who earns more than that. Okay, so the outer query is dependent on the inner query. Scalar subquery. Scalar subquery, as the name itself says, the scalar subquery result exactly one value. Okay, scalar means one value. Okay, so the same example, average salary, it returned one value, which is this 90,833, and you are selecting employees where salary is greater than the average salary. Okay, so moving on, in with using greater than, you can also use equality symbols. For example, you need to know who owns the most. So definitely, if I will just execute it, it should be CEO. Oh no, but Alice earns more than CEO. I think in the employees table, let us see if there is a CEO entry or not. Okay, no, maybe Alice is the CEO, I'm not sure, but she earns the most over here. Okay, so first you need to know the max salary. Okay, and then you need to know who has the salary which is equal to the max salary. This will give you who earns more. Now to delete the contents, delete the result set, means clear result set, it will just clean up your space over here. Okay, and we can just move this aside. Now if you see, this inner subquery result returns not one value, more than one value, but you are using the equality sign here for, and this compares every row. So every row it is comparing with multiple row, which is wrong. With equality sign, you should have one thing should compare to just one other thing. Okay, ideally else you should use an in operator, which we will see in later symbols. It's saying where salary is equal to, select all the salary from employees, which is wrong. It doesn't make sense. So this will throw us an error. Okay, if you will see, this will throw us an error. Row subquery returns more than one row. Okay, so it's a single row subquery, means it will compare row by row. But what to do in that such cases, you can use an in clause. For example, you need to know employees working in departments that have budget above 1,50,000. So we saw the departments table earlier, and we understood that the department table have a budget column. Okay, so if you see over here, the department table has a budget column. So we want to know every employee who works in departments that have a budget more than 1,50,000. 150,000. Okay, so first you select the department whose budget is greater than 1,50,000. Okay, and from the employee table, select those employees whose department falls under the department which is selected from this query. Okay, so this query will give you a result set. Okay, and it is checking the department of the employees falls in this result set, and this result set contains department whose salary is greater than 1,50,000. So basically this consists of this particular departments, these departments, only two departments. Okay, so only those employees which fall in these two departments it is checking. We have already covered the syntaxes of in and everything previously. You can just go over in, aggregation, everything. You can just make yourself comfortable by seeing the earlier tutorials. Now exists clause is very important. Okay, it shows does a matching department exists, means exist means it just wants you to check whether a condition is true or whether it satisfies a particular condition. It doesn't really returns a value, it doesn't need a return value. The idea is to just check a condition. For example, this particular query, inner query, is dependent on outer query. For example, it returns 1 from departments table where department id it has given an alias for department table where d.department id is equal to e.department id. E is nothing but employees table. Okay, so it select employee name from employees table where the employee department is present in the department table. Okay, and the condition returns 1 when the employee department is present in return table. You can return any column from either department or employee, but for the sake of simplicity and for the sake of like mature SQL scripting, we just return 1, because the idea is not to return a column but to return just some value, and that some value is 1 here. Okay, we return 1, select 1 when this condition is satisfied. Okay, when a department in department table is equal to the employees department. Okay, and exists checks if this particular subquery returns some value, any value. Okay, so this particular subquery return 1, the idea is to just to check the department if it exists in the master data. Okay, check the employee department if it exists in the master data departments. If it exists, then fine. If it doesn't exist, then okay. Okay, so it will, then this where condition will fail. Also, under, see here, this is the where condition. Select 1 from department where, not an on condition. Don't confuse with the join on condition. We have previously covered join tutorial also in Snowflake itself. That also you can check. Okay, so moving forward, so does a matching report exist? Yes, keep employee, no discard employee. This is called correlated subqueries, because the inner query is dependent on the outer query. More into correlated subqueries. If you see non-correlated subquery, first this query selects the average salary of employee, and the outer query checks the salary greater than average salary of employee. These two queries can be run independently. Okay, it is theoretically it can run independently, where salary greater than, if you give the max more the average value, the outer query can also run just the scalar value. Okay, but so these are non-correlated subqueries. But if a correlated subquery, if we, let's see an example of a correlated subquery. For example, we need to find the employees earning more than the average salary of their own department. For example, if you have an employee table like this, and for example Alice and Bob department is 101, so you need to find the average first, and then you need to find who earns more than the average of this 101 department. Okay, so that is your requirement. So firstly you will select employee name, department and salary from employee E, where E dot salary is greater than, you need to select average salary from, again employees table, you will alias it with a different name E2, where average salary of the employee table, where the salary of that particular employee is greater than the average salary of the department where that employee belongs to. How to check that? So you need to check the employee department ID is equal to the employee E2 department ID. Okay, so you need to check for calculate the average of the entire department. How will you get this department? Which department? You need to check based on the outer query. Okay, so for all the employees, based on the outer query, you need to calculate the average per department. Okay, not the entire table, per department. So you need to check whether that employee's salary is greater than the average of his department. So you see these two are related. Outer query is referencing department of, inner query is referencing department of outer query. Okay, so this is conceptually what happened. Employee A calculate the average of A's department, compare employee B, calculate average of B's department, compare employee C, calculate. That's what it is doing. Okay, so it is calculating average of every employees, and then it is actually comparing with the department average. Okay, now when you see a subquery in the from clause, it is generally a derived table. Derived table means a temporary result set. Okay, so this particular subquery returns a department and average salary from the employee. Okay, so this particular subquery returns that result set. Now you have to find out the department ID and average salary from this result set, where average salary is greater than 90,000. Okay, so from the inner subquery you need to find out, you will get the average salary, and the outer subquery will further refine that particular result set using a condition. So this from clause, when you write some query in the from clause subquery, that becomes the derived table. Okay, So previously, subquery produced a value, okay, like a scalar subquery. Now here, in case of derived table, it produces a table from where we can select and apply further logics like filtering, etc. Moving forward, subqueries are powerful, but business logics becomes complicated. They can become difficult to read. Take an example. Just don't go through this query line by line, but understand what it is doing. Okay, so here it is first finding the VP of engineering, where title is equal to VP of engineering. Then it selects employee, okay, where manager ID is equal to VP of engineering from the org chart. That means who report to the VP of engineering. Then it has one more and in the where there are two conditions. One is the manager should be in manager should report to the manager who reports to the VP of engineering. Okay, so two level hierarchy, and the average salary should be, there is some logic for the average salary of that particular employee should be greater than some value. Okay, so wouldn't it be easier to give each step a name, okay, rather than writing like this? Sorry, okay, so wouldn't it be easier to give each step a name? That is where common table expressions come in. So a common table expression or a CTE lets you give a temporary name to a query result set and then reference that result in the same query or the following query. Okay, so if you see, the syntax is with CTE name as select and then select from this CTE name. So this result set, you are giving a name over here. Let's check an example. So select department ID average salary as average of salary as average salary from employees group by department. This is giving a result set. Okay, we are giving it a name, department average salaries. This is getting the average salary per department. Okay, and then we are actually selecting from this CT. Okay, so this kind of what same thing what we did in derived table where we wrote a query in the from clause. Here we are explicitly giving a name to the result set, giving a name to the query. Okay, and then from that query we are selecting the value. Okay, so yeah, this is the same thing. Just like you give, like a query can also be given a name like of a view, like you could create a view, that is nothing but naming a query. Similarly, you are not creating any artifact here, you are not creating any object here, just temporarily you are giving it a name and selecting from this particular named query. Okay, where average salary is greater than 90,000. Okay, so this is the syntax with create a temporary result, department average salary, and then use it in final query. Now CTE versus derived table. So here is an example of derived table where in from clause you are writing a query where you are grouping the average salary by department and then filtering that. But with CTE you are first naming this, okay, and then you are filtering the average salary from this named query. You are writing the name here rather than writing a from query inside the from clause. So this looks cleaner. Okay, you understand what you are doing here, and then the final query is you are applying filter on top of this result set. Okay, so basically CTE and derived table, they can solve similar problems. The major advantage of CTE is readability and the ability to break complex logic into named steps. So one more example. So how we like build a pipeline with a CTE. Like first we create a CTE and call it department stats, means statistics for the department. What is that? For each department ID, get the average salary and the number of employees per department group by department ID. Okay, where department ID is not null, I have given a condition, call it department stats. Similarly, call it budget, high budget departments, like all departments who have budget greater than 1,50,000. So if you see the department table over here, department, so every department is having a budget over here. Okay, so every department who has a budget of 1,50,000. So yes, I will also connect my notebook. It got disconnected. I think it got disconnected. Okay, and then after you have two CTEs over here, you can kind of join those two CTEs also. If you see, you take department name from department and then join high budget departments with you give it an alias as D with on department ID. Okay, so you can join the CTEs also, not just like filtering it over here. Okay, now CTEs versus subqueries, when to use what? So you should use subquery when the logic is short, result is used once, and the query remains easy to understand. Okay, so long story short, you should use a subquery when the logic is simple, like you need to find the salary which is equal to the max salary of department, or a simple scalar subqueries, those kind of scenarios. But when the logic is complicated, okay, when the query has multiple logical steps, you need logic needs names, okay, query becomes deeply nested like we saw, from inside out you need to traverse, okay, easier debugging, you create a subquery. Okay, so what is recursive CTEs? Suppose we do not know, the level of hierarchy is unknown. Okay, for example, the VP reports to CEO, director reports to VP, manager reports to director. Similar, you don't know where it will end. Okay, there will be 3, 5 or even 10 levels. That's where recursive CTEs becomes useful. Now recursive CTEs has two parts. One is the anchor member, and then there is the recursive member. Anchor member means where does the recursion start. You need to manually key in the member, who is the first member, and then you have to union with all the members whose manager we have already found. So for first iteration, the manager would be the one we have coded manually, okay, the anchor member, and the next recursion it will, and that anchor member will be unioned with all people who report to first member, and then it will call this CTE again, org hierarchy CTE again, and then find all the employees who report to all the employees we already found out. So recursive member, it what it does is that it finds employees whose manager is already we found. Okay, that is what recursive member does. We follow a top down approach. Okay, so we are following the org hierarchy table, org chart table over here. Okay, sorry, now here you have the employee, you have the employee manager ID of the employee, okay, and you see who is the employee. So the first person who will be the manager will have a manager ID of null, because Sarah is the CEO, she doesn't have any manager. So this will be our condition to define the anchor member. Where does the recursion will start? So we will select employee ID, employee name, title, manager ID. We will hardcore one as level, hierarchy level, because she is the first member. Okay, now we also want to create a management chain. What is a management chain? If you see the result of this, okay, if you see the result of this, here is a management chain. Now Sarah, I'll not, if I'll just take this, I'll just show you how does it look, management chain. Okay, so if you see the management chain here, Sarah, then Michael reports to Sarah, Elena reports to Sarah, David reports to Michael, reports to Sarah. This is a management chain. Okay, we want to create such chain, we want to create such diagrammatic representation of the organization hierarchy. So for that we will first start with Sarah. Okay, so first if you see it started with Sarah, so we will take employee name as management chain. Okay, we are just casting it into varchar. Okay, and what is the condition of our anchor member? Management ID, if you see here, should be null. This is our first member. Then we will union with all the people who report to this. Okay, how do we find out they report to the first anchor member? Whose manager ID is equal to the employee ID we have already found out. How to know what people who we have already found out? By calling the same hierarchy, same CTE, same hierarchical CTE. It is the hierarchical CTE, sorry. So first we will take out all employee from org chart, and we will check in the same hierarchical CTE, org hierarchy, if the manager ID already exists there. Okay, so we are checking whether our manager ID of the employee in org chart is already existing in org hierarchy, and already we have started populating employees in org hierarchy. So after first iteration it will have so no, don't call it an iteration, this is not a loop. Okay, so just see how it will work. So first it will find out Sarah. Okay, and then it will find out all the employees that is reporting to Sarah. Okay, so suppose it will find these three employees. Now this particular CTE will have these three people. Okay, now this particular CTE will have these three people. Now after that it will again call the same CTE. Okay, it is again calling the same CTE and checking all the people whose manager we have already found out. It is again checking the getting all the people from org chart hierarchy and checking his manager ID is already there in H. H is nothing but the hierarchy alias of the same CT who is already present in the CT. So recursively it is starting with the anchor member. Recursively it is checking all the employees who report to the anchor member, and then it unions it, and then it creates a set. Then it again checks all the employee who reports to these results set. Okay, then again all the employees who reports to these combined results set. Okay, and continuously constructs a management chain. Okay, so existing management chain, it appends the all the new employees it has already found out. Okay, over here it finds all the new employees it has already found out. So this is what it does, and this is the simple concept of recursive CTs. But sometimes what happens is that there are errors in the system wherein suppose Sarah reports to Michael and Michael again reports to Sarah. Somebody by mistake has created a hierarchy like that. Okay, to avoid those errors you just put a where condition over here where H level, you just give a hypothetical level. Okay, H level is equal to like 12 or 100. Okay, in that case if there is a cyclical error it will not run, else it will run forever. Okay, and you may end up with a good Snowflake bill. So yeah, thank you all. That's it. We will see you in the next video. Bye.